I want to take a look at one very special exponential function, and that's going to be the one that has the base of e. So if I look at f of x equals e to the x, e is a number. E is approximately 2.7. Okay, it's actually an irrational number, so it's like pi and the square root of 2. The decimal expansion, if I were to write it out exactly, it goes on forever and ever and ever without ever repeating a pattern. Okay, and so we just call it e. Okay? And I will expect you to write things in terms of e. I don't want rounding, so don't write 2.7 instead of e, but it's useful to know that that's about what e is, because that's going to help me in graphing. Okay. Now you might say, why would we want to work with such a weird number instead of something nice like 2 or 3 or something like that? The number e actually shows up in the natural world. Okay. Things that change at exponential rates can often be described using that number e. And we'll actually see in the financial world, if we look at interest that's continuously compounded, and that'll be defined soon, we're going to see the number e showing up there as well. So if I were to sketch this, I'm going to do this very quickly. I don't need a full-on table of values. I know that that's bigger than 1. So it's going to be exponential growth. So I'm just going to plot 3 points. I'm going to plot my y-intercept. That's always just 0, 1. And then I'm going to plot 1 point to the right and 1 point to the left so that I get about the right rate of steepness on either side. So when I plug in 1, I know I'm going to have the point 1e. Since I know e is about 2.7, I can say, okay, come over 1, up 1, 2, here would be height 2, here would be height 3. 2.7 is about there. I'm going to make sure I label that 1e. I'm not labeling it 2.7. I'm labeling it as what I want it to be. I'm just using this to estimate where to put it. Okay. And then on the left side, I know that if I go 1 to the left, so my x value is -1, my y value would be the reciprocal of e. Well, if e is between 2 and 3, its reciprocal is between 1/2 and 1/3. So that's going to be there-ish. So there's my -1, 1 over e, or I could write it as e to the -1. Either is acceptable. Okay. And so there's my graph of e to the x. Excellent. Okay. So we will be working with that base a lot, so make friends with it. Some of the homework asks you to use a calculator to evaluate things. Do use a calculator as you're doing that, okay? But be prepared on exams and quizzes to label things exactly, and to use this to approximate where to put things so that your graphs are accurate. All right, what I want to do next is start taking a look at some transformations of graphs. So back in the first chapter, I think it was the first chapter, we looked at transformations of graphs. Now we've got new parent functions. We can take an exponential function as our parent function. So here's what I want to do. I want to do 2 things. First of all, I want to graph f of x equals 2 to the x. And I'm going to include the points whose x values are -1, 0, and 1. Okay. So I'll include the y-intercept and then 1 point on the right, 1 point on the left so that I get approximately the right growth rate going on both sides. Okay, and then I'm going to use transformations to graph g of x, which is going to be -2 to the x plus 3. Okay. All right. So, and as I'm using these transformations, I'm going to keep track of where these 3 points get transformed to. Okay, so let's start out with question number 1. We're graphing 2 to the x. So 2 is the base, it's bigger than 1, so I know we're going to have exponential growth. My y-intercept is 0, 1. When x is 1, we'll be at a height of 2. When x is negative 1, we'll be at a height of 1/2. Okay. If you want to create a quick mini little table of values here, you certainly could. Not necessary, but perfectly acceptable. Okay. All right, so there we go. So now I want to use these transformations. So I'm going to create my little table, not a table of values, but a table that lists what I would do to evaluate the function and then the corresponding transformation of the graph. One thing to be very, very careful of here, this is not a base of -2. The base is 2. Might be helpful to rewrite that as -1 times 2 to the x plus 3, because that's what it means. The rule is exponents act on what's immediately next to them. So the only way that negative would be part of the base is if I had it in parentheses. Okay. It's not in parentheses, so I'm going to take 2 to this power and then multiply the result by -1. If you're at all likely to get confused, rewrite it like so. Okay. I can also, if I want, although I don't have to, I can put that x plus 3 in parentheses because that's all up there in that exponent position. And that might help me to see that that one thing is going to be my exponent. So if I were to plug in a number for this, first thing I would do is I would add 3 to the x. Okay. Once I have that, that gives me my exponent. Now I'm going to do my exponentiation. So take the power, which is my parent function. Okay. Once I've got that power of 2, then I'm going to multiply by -1. Okay. Now remember our rule, anything we do before we evaluate the parent function is going to affect the graph horizontally. Anything we do after the parent function is going to affect the graph vertically. Okay. In this case, I just have one horizontal and one vertical transformation. So it doesn't matter what order I do them in, because it never matters whether I do vertical or horizontal first. If I have multiple transformations in either category, I always have to make sure I'm working away from the parent function. Okay, so what does adding 3 do? Remember that horizontal transformations are a little bit counterintuitive. So that's going to actually move things 3 to the left. Multiplying by -1 is going to be a flip. And this is going to be a vertical flip. Okay, so I'm going to go ahead and graph this. I'm going to just graph this one transformation at a time. For the sake of showing your work, okay, you need to have this graph, because that was the answer to 1. You're going to need to have the final graph for question 2. I need to see what transformations you're doing. So I either need to see this list written out, or I need to see you do them one at a time. Up to you. I'm going to actually do both. Okay. So if I'm moving things 3 to the left, okay, that's going to be a horizontal change, so that's affecting my x values. So I'm going to do the opposite of this. I'm going to subtract 3 from each of my x values. So this point is going to get moved to -4 1/2. This point is going to get moved to -3 1. And this point is going to get moved to -2 2. Okay, so those are my points. Anytime I'm doing a graph with an asymptote, I have to see if the asymptote is affected. This was my asymptote. We're sliding everything 3 units to the left. It's still at the same height. Okay, so the x-axis is still a horizontal asymptote. My graph's going to look something like so. Now I'm going to do the vertical flip. That's going to keep those x values the same. Now I'm changing my y values, and I'm doing exactly that to them. I'm going to multiply them by -1. So I will have a point -4 1/2. I will have a point -3, -1, and I will have a point -2, -2. And then when I connect those dots, the x-axis here is still a horizontal asymptote, it's just we're now below it and decreasing. Okay. We will eventually cross the y-axis, although this graph gets fairly steep, so we're going to be pretty low down before we actually graph that. Okay. So this is just applying what we've seen before with transformations, but applying it now with different parent functions. Now we're allowing ourselves to use exponential functions as the parent graph.